Hello everyone, welcome back. In today's video, we are going to talk about creating our own machine learning program using Python, using scikit-learn. This program will detect or will can be used to detect whether a person has breast cancer or not, or whether a tumor is malignant or benign, to be very specific. We are going to import sample data set from scikit-learn. Okay, we have sample database which is made available to us. We will describe the data and see. So we do have breast cancer data available. We will use that data to train our model and then also to test our model. So if you have not done already, you have to do pip install scikit-learn. Once you have installed, you will get the sklearn library or the modules. You will get all the modules and you will also need pandas. So here you go. You can create and train your own. This is just a function. You load the data set and this is the function. Here, this is where we have imported sklearn datasets. It has an inbuilt method which is called as load breast cancer, which will load the data set. Now this part I am doing only to print it so that we see what the data looks like actually, because we don't know, it's being loaded into a variable, right? For us to get more information about the data, this is the method DESCR, which describes the data set. What is the data set? It will, when I run the program, you will see it gives complete information about the data sets. And this is just to print the head or of the, which means the 5 columns, for top 5 columns from the data frame. So just we can have a look at how the data looks like. X and Y, okay? So this is the breast cancer data actually, okay? The various features and what its value is. Target. Target has 2 columns, whether it's 0 for malignant, 1 for benign. Okay, benign means the tumor is, it's not cancerous. Malignant means they have seen traces of cancer in the tumor, or they have detected cancer cells in the tumor. Split the data into train and test. Okay, so X is the data, Y is the label. Okay, so you split it. Test size is 0.2, which means 20% is, if we take it as 100%, 20% is the test size and remaining 80% is the actual, what do you call, training data. Okay, and the random 42 means every time shuffle the data 42%. Okay, like otherwise if we repeat the iterations, as you see, we go through 3000 iterations to train the data, it will pick up the same data. So this random state means shuffle the data. Okay, 42% of the data shuffle every time when you do the iterations. We are using logistic regression. Okay, that's our model. It's a linear model. We fit our data, okay, to the model, or train the data. So this method, we call it to train the data. We predict the data, okay, using the test set, training set, and test set. Okay, so we train the model on the training set, we test it on the test set, and we see the accuracy score, like how much accuracy or how much accurately did our model was able to detect cancer in the test data set. So predict new data model, simple, get it. You just print the lab sample data and predicted class. Okay, so this was the data and this is what it predicted. So you're just printing it. So you're calling the test data sets, you're passing it to the model.predict, and you're just printing what the actual model predicted. Okay, let's see that in action. So I already have created a file, breast cancer detection.py. I will run Python and see here. Let's see what happens. Let's go through the output first. So here you see the DESCR method. Where is it? It was here up. This one, you're describing the data set, which is here. See here. So you have 569 instances or rows of data available. It has 30 attributes or 30 features. Each row or each piece of information has 30 features. What is the meaning of each feature? What does radius means? What does the texture mean? What is the perimeter? What is the area? What is the smoothness? What does each piece of data mean? Okay, so we are getting a complete detailed information. Two classes, malignant and benign. So 0, if a model predicts 0, which means it's malignant, the tumor. If it predicts 1, it's benign. Summary statistics. So this is just a summary, the mean of everything. So you get to see in detail, you can visualize the data because it's not like a CSV file which is downloaded. It's downloaded or stored in a variable. So for you to get a better picture so that you can visualize, the describe method is there. There are no missing attributes. So out of that 569, 212 are malignant, 357 are benign. Who's the creator, who's the donor, when it was created, where it was created, in the Wisconsin, all the features, everything, complete information. This is the some sample data, the top 5. This is how the data looks like. Okay, the 30 features, what are all its values? And as you can see, after you test the model accuracy, we see it's 95% accuracy. Sample data, so see it, actual class was 1, the predicted class was 1, and the actual class was also 1. Predicted class was 0. So the model was pretty accurate in predicting in 3 rounds, in the 3 sets of the. Now what we're going to do is let's change the test size. Okay, let's make it 30. So test is 30, train is 70. Okay, so we have changed how much data the model should use for testing and how much it should use for testing, training. So let's see how it affects the model accuracy. When it was 2080, accuracy was 0.95% or 0.95%. Let's see how much it is now. See, it became 97%. So what happens is you increase the test size. So now the model is using 30% of the data for testing and it was trained on 70%. So the accuracy of the model actually increased. Okay. So again, this is a very simple code. Again, we are using scikit-learn. We import, we load the breast cancer data. This is just for us to visualize how our data looks like. Pretty simple. Training and testing of the features, training and testing of the labels. Random will shuffle the data in under every iterations because we are going through 3,000 iterations. So every iteration, it will shuffle our data. And this is nothing simple. What you're doing is taking some random test data and trying to predict it. Okay, and we are running it 3 times. So that was it, pretty simple. As you can see, it's not very difficult. Machine learning, if you know, I mean, there are lots of models already available. like this logistic regression. And also scikit-learn has lots of models, not only breast cancer data, but it also has a lot of like flower detection, the famous iris detection, so you pass a lot of flower images, and you again pass some new flower image and try it, make the model detect it. A lot of examples and data sets available freely. Okay, so that was it for today. Thank you all for your time. Feel free to like, subscribe, so that you get notifications of future AI and quantum related videos. All right. Thank you all for your time. See you all again next time. Bye.